Hello everybody, today is December 19th, 2020. Um, Coming to you from New York City. This will be a little video to show you the changes I've made to the ADF4351 and running some tests with my spectrum analyzer, and we'll see what the scope says as well. And let's begin. Okay, so as you can see, I have mounted the device on a little metal box. Um, It's not supposed to look pretty. It's just supposed to be functional and something that is really tough, and it doesn't put any stress on the SMA cables, which was a real big problem. And it's not only that, plus if you don't have a case like this, a metal case like this for the unit, you're constantly messing around with touching the PCBs, and just it's because it's exposed on all sides. So I don't want to think about shorting anything or anything like that. I like the way it is. If you notice that I put it towards the top, so this way there's easy access to the on and off switch. The USB connectors on the left. The two SMA connectors are on the right. And the connection on the other side is the BNC male. BNC female connectors. Okay, so the hole that I had to drill was 489 mils, as you can see written on the case itself. I'm holding it down with a clamp, which works really well. And the other thing that you should notice is that I am actually feeding it an external source, an external 10 megahertz source, which is coming from my GPS clocks. Okay, so this is what the little machine looks like. I think it's really happy in its case. Let's start by looking at the schematic, and I'd like to show you the changes that I've made over there. Okay, that's it for this. Okay, so here we have the ADF4351 schematic, and as we can see that right over here, right here is our crystal. It's a 25 megahertz crystal, and it has pin number 3 is the output, and the whole thing is fed from DVDD, which is I believe 3.3 volts, and L1 right here is the coil that is used to feed the power to the crystal. The coil through it which the power is being fed to the crystal. So if we take out this coil, actually we will have no power coming into X1. Now, my idea here was that the M clock output, if I disable the crystal and I just feed a 10 megahertz signal to the M clock SMA pin connector, it will go through C9 DC block and 51 ohms R6, and it will go through C10 again and ref in. Now ref in, as you can see, is right here. Okay, so I think disabling the crystal is the right way to go. Now, some other YouTubers have suggested that we leave the crystal running and remove R5. R5 is right here. I don't think that's a good idea, because we have some crosstalk from pin 3 to C9, and if we then feed signal to M clock, the crosstalk will have, so C9 will see whatever crosstalk is coming from pin 3 from the X1 and whatever frequency we're feeding into M clock. So now this is probably not going to be something significant, but however, anything is significant, right? So I wasn't comfortable with that. So I decided to remove L1 altogether, and then X1 will be disabled. Now, the thing that I haven't really tested is if I am feeding a signal to through M clock, I should really take out R5 as well. So I'm not feeding M clock to the output pin of X1 as well as going to C9, right? This would be a problem perhaps if the output pin is maybe very low impedance. If it's really high, then I don't think it really matters. But we'll see. I mean, I did not take out R5. There's a lot of little surface-mounted components there. I didn't want to mess around too much with it, so I did not remove the R5. Okay, so that's it. As we can see from this picture, L2 has been removed from the power input to the crystal. Okay, first things first. Let's put the standard frequency we're using. That's the coming in from GPS. Let's see what it looks like with a spectrum analyzer. Okay, so that's a 10 megahertz signal. I'm going to feed it to the spectrum analyzer and do port select R2, increase auto scale. Okay, and let's start at 0.1 megahertz and stop at I don't know, 50. Okay, so let's do a start 0.1 megahertz, and let's do a stop at 50 megahertz. Okay, so as we can see here, we have some spikes. Let's auto scale this baby, and let's get maximum is okay. So I have a wide range here, so I'm not going to get an accurate reading, but as you can see here, my frequency standard input to the spectrum analyzer, well, this is a network analyzer, the 4195A, is coming in from an external reference source. Okay, so the major spike we see here is at almost 10, it's at 10, close to 10 megahertz. Next peak, that will be 20 megahertz, right? So let's do a max, and just for the hell of it, let's do a start at 9 megahertz, and let's do a stop at 11 megahertz, and let's do a max. Yeah, just as I thought, right? Do it, auto scale. There we go. 10 megahertz, right on the money. Okay. All right. So let's now take this and use it to feed our little device. Let's do that. Okay, so I reconnected the device. I put the 10 megahertz standard input to it, and now it's time to see what the outputs look like. Okay, so first thing I want to show is what our spectrum analyzer sees, and I'm going to change that right now. Okay, change that right now. Right there. Okay. Here we go. So as you can see, our first marker is at 50 megahertz. The next peak is at 150. The next is 250. No, 248, but it's actually 250 because I have a wide span on the spectrum analyzer, and then it's 350. Okay, so that's what it looks like on the spectrum analyzer. And now our frequency counter says 50 megs right on the dot. Okay, and let's double check that. Let's see what our second frequency counter says, and he also says 50 megs right on the money. And I need to point out that all my instruments are synced to GPS. So, and last but not least, our scope shows the waveform. I did make that a little bit better. There we go. Okay. Of course, we don't expect to see a perfect sign because we know that there are other spurs in there. Okay. There we go. So, overall, I think this has been a good exercise with a little device, the ADF4351, and this puts an end to my first YouTube video. Thank you everyone for watching. If you like, subscribe. I will add more. Thank you.